So hello and welcome to another video from sickmaths.co.uk, where you can find lots of free maths videos both for GCSE and A-level. This video is for the Mechanics 1 M1 module in the A-level Edexcel syllabus, and we're going to be talking about momentum and impulse. So first of all, what is momentum? Momentum is calculated as mass of the object times its velocity. So say we're calculating the momentum of this, and we're considering the right direction, this direction here, as positive. So basically we simply do mass times velocity 2 times 3, which is 6. Okay, so the momentum of this is 6, and the momentum of this one, which is moving in the other direction, is going to be 5 times minus 4, because the right direction is positive, therefore the left direction is negative. So 5 times minus 4, which is minus 20. So the momentum of this is 60, and the momentum of this is minus 20. Okay, now most of these questions are to do with collisions, okay? Almost all of these questions are really to do with collisions. Momentum questions and impulse questions are to do with collisions. And the way we do them is we consider the momentums before the collisions and the momentums after the collisions. And we use this formula generally in most of these questions. The momentum before is equal to the momentum afterwards. So if I add the momentum of this to the momentum of that, that's the momentum before, and add the momentum of this and that together, that's the momentum afterwards, and that momentum together should be equal to the momentum of the after situation as well. So what's the momentum before? It's 6 plus minus 20, which is minus 14. So momentum before is minus 14, so I've done that calculation there. 2 times 3 plus 5 times minus 4 is momentum before. And momentum afterwards, well, that's 2 times minus 4, because that's the negative direction. So 2 times minus 4 plus 5 times v. Now I'm trying to work out the speed of B after the collision, right? And I don't actually know that it's going off to the right rather than the left, okay? But you generally tend to use the positive direction as the direction which the object is moving, unless you know something else that tells you that it should be going towards the left, say, instead of the right. Okay, and the reason why we use that is even if I pick the wrong direction for the velocity, if I get a negative answer for v, that means it was actually the other direction. Now if I choose a negative direction and get a negative answer, it's really confusing. Negative means positive. Yes, that means it's the opposite direction, but it's just generally a lot more simple to simply choose the positive direction for a velocity if you're not sure which way it's going. Anyway, so I've got 2 times minus 4 for the momentum of this, and the momentum of this is 5 times v, which is just written as 5v. And if I simply rearrange this and make v the subject, I can easily work out that v equals minus 1.2 meters per second. But I actually wanted the speed, which is slightly different to the velocity. Velocity is a speed with a given direction. So if I don't need the direction, the speed is simply 1.2 meters per second. And that's it, really. Let's move on to the next part of the question, which is saying, does B change direction after the collision? So that's before collision, as we were saying, and that's the after collision. And before the collision, it was going this way towards the left, okay? And we're told, looking at the sign on the velocity, the negative sign on the velocity, you can see that it's not going in that direction, it's going the opposite of that direction, as we said. Yeah, it's got minus 1.2, so it's minus from that direction, which means really it's moving towards the left. If it was a positive number, it would really be moving towards the right, okay? So sorry, I had to pause the video just then. So basically it's continuing in that left direction, so no, we have not changed direction, because it was going in the left direction before, and now it's continuing in the left direction, and that is it. Part C, find the impulse on B by A. Okay, basically we're looking at object B because it says on B, so we're looking at the impulse on B, so that's the thing we care about. Okay, and what is impulse? Impulse is equal to the change in momentum. It can also equal impulse can also equal force times time, but we're not interested in that. We've only got the momentum and no forces involved in the question, so just use the change in momentum, and that's calculated as either you can write mv minus mu, where v is the final speed, is the speed after the collision, and u is the speed before the collision, or you could just do it in the factorized form like I've done, m brackets v minus u, which means the same as mv minus mu. Anyway, so what is that? So we're looking at object B because the impulse is on B, so just bear that in mind always. Wherever it says, wherever the impulse is on, that's what we're looking at really. We're not looking at A really. A is just the thing that did it to B, but we're looking at B. So let's look at B, and the momentum before was, if we're looking at that the right direction as a positive direction, therefore that is still minus 20. Oh, sorry, we're looking at we're using this method, aren't we? So m is 5, initial velocity is minus initial velocity is minus 4, and final velocity is minus 1.2, which we just calculated there. That was that. And do the taking away, so minus 1.2 minus minus 4, which is the same as 4 minus 1.2, which is 2.8 times by 5 gives you 14. Now, how do you know that it should be 14 Newton seconds? Well, how do we know the units for impulse or momentum even? Because to change momentum should be the same as momentum, which is Newton seconds. Okay, so the answer is that the easiest way to know the units for impulse or momentum is to look at this, because impulse is measured by force times time, Ft, and force is measured in newtons and time is measured in seconds, so therefore the unit is Newton seconds. Okay, so the answer is 14 Newton seconds. Now let's move on to question 2. We've got our before the two we got the situation before the two particles collide and after. Notice that there is only one particle, because this is a situation when the two particles coalesce. That means they stick together. So this was going towards this particle here, and this is going slightly faster than that one, so eventually it catches up, and when they catch up, it's like plasticine or something. They just stick together and they've got a combined mass. So it works the same the way as before. Momentum before is equal to momentum afterwards. So momentum before is 4 times 3 plus 3 times 2, 12 plus 6, which is 18, is equal to momentum afterwards. So their combined mass is 4 plus 3, which is 7. We don't know the speed afterwards, that's what we're trying to work out, velocity there. So if we've got this equation, 12 plus 6 equals 7v, because mass times velocity should be the momentum afterwards, you got 18 equals 7v, just rearranging gives you v equals 18 over 7. And that's the speed, meters per second of course, but whatever. Okay, another situation where they're effectively coalescing, where basically they're getting stuck together, is when you've got a string, in the beginning is slack, okay? And it's going, this one's going at 3 meters per second, this one's going at 6 meters per second, so this one's actually getting faster and further away from this until it becomes taut, at which point they are basically going to go at the same speed, which is effectively like this, coalescing basically. Okay, so you treat them as one object of mass 9, because that's mass 4 and that's 5. So looking at the momentum before, we got 4 times 3, which is 12, 5 times 6, which is 30. They're both going in the same direction, so we're considering the right direction as positive, as we have been for all these questions so far. So anyway, so that's 12, that's 30, the momentum for that, and the combined momentum is 4 plus 5, which is 9 times v. So just rearranging again, that's 42 divided by that 9 gives you the velocity of the combined little thing there, that velocity there. basically. Anyway, let's go to another question. We got a racket hits a ball. This is a ball, by the way, and the racket meets the ball for 0.03 seconds. Okay, and we're saying before the ball hits the racket, it's going at 2 meters per second, so 3 meters per second towards the racket. And it's 2 kilograms, a very heavy ball, and after the racket hits it, it moves the other way, of course, at 4 meters per second, and of course the mass is the same, which is 2 kilograms, because the mass of the ball didn't change. I suppose it could have, but it didn't. We're keeping it simple. Find the force on the ball. Basically the force applied to the ball. So as we mentioned earlier on, impulse can be measured in 2 ways, or 2 ways at the same time really. That impulse equals force times time, which also equals the change in momentum. So Ft equals m bracket v minus u close bracket, or just mv minus mu, same thing really. Okay, so we don't know the force, but we know the time that the force was applied for, which is that, and we do know the change of momentum, which is very simple. You do the mass is 2, so that's 2, velocity afterwards is 4. We're considering the right direction positive, and therefore since that's going towards the left, that's minus 3, so 4 minus 3, which is 7. So 7 times 2, which is 14, divided by 0.03, and whatever the answer to that is the force in newtons, of course. Okay, the force applied by the racket on the ball. That's another one done, and let's go for our final example. We've got 2 objects, and this is interesting because it's not really using momentum before equals momentum afterwards. It's kind of a tiny little thing on the side. Basically, sometimes you have to do these interesting inequality things and all this kind of stuff, and it's based on knowing a bit of common sense, I suppose. If you look at this before situation, you've got an object moving at u meters per second and another object moving at 2n meters per second, and of course, and there's another after the collision, that object is moving at u still for some reason, and this object is moving at 4 meters per second. So we want to know something about n and u, and this is what we realised that this is what we want to show. We want to show that 4 is greater than u, which is greater than 2n. How do you do that? Well, as we said, a little bit of common sense. If there are to collide, so this is before the collision, this is after the collision, that means u must be faster than 2n for them to collide ever, right? If that was slower than that, they would never collide. So u is greater than 2n, that's the B stands for before, so before situation tells us that u is greater than 2n, and the after situation tells us, well, if they've collided and they're separating and they're both going in the same direction, that means that must be faster than that, right? Otherwise they'll be colliding again or something. It just wouldn't make sense. Okay, so that means 4 has to be greater than u. And basically, if 4 is greater than u and u is greater than 2n, that combined together tells you 4 is greater than u, u is greater than 2n, can be written as a single inequality, and that's it really, just a bit of common sense there. So I like to round up, mostly just use momentum before equals momentum afterwards. Also bear in mind that impulse equals Ft, which is equal to change in momentum, and that you can get different situations where we coalesce, either they physically coalesce or they effectively coalesce by being connected to a taut string. Yeah, and then you got this funny business on the common sense business, I should say, over here, and that's it really.